Good day, everyone. Today we are going to work on our linear systems of equations, and we have many different forms for that of ways to solve. We can graph, we can solve by substitution. There's a couple different ways to look at substitution, and we can also do linear combinations, which is also known as the elimination method. So quite a variety of skills here, but those skills are needed in Math 2 and Math 3 in terms of solving for quadratics and higher order polynomials. So it's a great skill to learn, and we're going to learn it with linear equations where there's an x and a y in that equation, and they're each only to the first power. So in this video, which I'll walk you through, we are just going to solve by setting the two equations equal to each other and solving algebraically. They are y equals equations, both of them. So when you see y equals in your starting problem to solve a system of linear equations, what that means is you could graph them, because graphing in the graphing form y equals mx plus b is a super easy thing to do once you realize the elements of the equation, what they mean. But if you were asked to solve using algebra, then there's another method, and that's what we'll outline here. So, and just because I'm pretty sure I haven't said it yet in this video, when you are solving a system of equations, that means you're looking for where these two lines, when they are plotted on a graph, a grid, that they intersect, and where they intersect is where we're trying to find out that point. And so our answers, our final answers, need to be recorded in point format. So I'll walk you through all the process, and let's get started. Good morning, everyone, or good day. We are going to do systems of linear equations and solving those. That's when two equations are graphed and we are trying to find where they cross each other. And that crossing point is called the intersection point. So we're going to do a certain type of solving right now that is setting equal to each other. It's a form of substitution, really. And so as you can see, these equations are both set to y. And that's the same y for this system. So if y equals negative 3x plus 4 and y also equals 3x minus 2, well then we can say that negative 3x plus 4 is actually equal to 3x minus 2. And now it starts to look like a solving of an equation that we've seen before. So we'll draw that scaffolded dividing line so you can see the left side from the right side. And now it's just a process of consolidation and undoing. So if that is a negative 3x, then we are going to add 3x to both sides. And what that will do is put all the x's together on one side, and notice we can cancel out negative 3x plus 3x is actually 0. And so those terms are gone, leaving us a positive 4 on the right-hand side. Now, 3x plus 3x is 6x, and minus 2 comes down because we've done nothing with it, and so we can't lose track of it. So we're undoing here also. We're going to add 2 to both sides. This has the same effect as we did for the x's. So negative 2 plus 2 will equal 0. And so now you can see these terms are canceling out on the right-hand side and consolidating on the left. And this right here is a really critical thing to notice. Now I've got a numerical component, just a number only, the 6 on the left, and I have 6x only on the right. And this is really the goal. I'm steadily trying to get all my numbers on one side of this blue line, on one side of the equation, and then only my x's, or my variable, on the opposite side of those numbers. And so the thing we need to realize is when we have, in order to do this step, what we have to realize is that when you have a number smushed up right next to a letter, that number is the coefficient, that letter is the variable. And when they are right next to each other with no space or symbol in between, it is always multiplication. You forever will always be able to assume that that is a multiplying relationship. And so how do we undo multiplication? We do division. And that's what solving is all about, is undoing all the undoing all the operations as they are written in the equation. And so whatever you do to one side, you continue to do to the other. And so 6 divided by 6 is 1, And you can see that's the effect on both sides. So on the left, we have 1, and on the right, we have 1x, which in the math world, we get to just write as x.